All right, on to page 2 of the review. Now we are multiplying. Okay, so when you multiply, it is inside times inside, outside times outside, as long as they have the same index. So here I would do 75 times 75, which is 5,625, and then x to the 7th times x to the 7th. I'm going to add those exponents. So it's x to the 14th, and all of this is under a big square root. So I need to simplify that square root as much as I can, and I would start with a tree for 5625. I already know that's 75 times 75, and then 75 I can break apart rather easily. 25 times 3, 25 times 3, and both of these 25s become 5s. I am looking for pairs, so I have a pair of 5s, a pair of 5s, and a pair of 3s. 5 times 5 is 25, times 3 is 75, so the square root of that is 75. The square root of x to the 14th is x to the 7th. Alright, the super fast way to do this is to remember that there's a rule. If I'm multiplying something times itself and they are both in the square root, then the final answer is just that thing without the square root. Okay, so in here we have the cube root of x plus 5 squared and the cube root of x plus 5 to the 4th. Okay, when I do that, I'm going to have the cube root of x plus 5. And because this is all one grouping, and I can add these exponents. So this would be x plus 5 to the 6th. Okay, the cube root of 6 divided by 3, is 2. So this simplifies to x plus 5 squared. Okay. Here we have two different square roots, so we're going to follow the same process that we did on number 13. I'm going to multiply first. So 5 times 15 would give me 75. A to the 7th times a to the 3rd. I'm going to add those exponents and get 10. And then I'm simplifying this. So my tree for 75 would be 25 and 3, 5 and 5. There's my pair, so that comes outside. 3 goes inside. A to the 10th, there are 5 groups of 2 in 10, so that simplifies to 5a to the 3rd. Okay, here we're going to distribute, so outside times outside, inside times inside. The square root of 6 times 3 is 3 square root 6. The square root of 6 times the square root of 6 is the square root of 36, which of course is just 6. So 3 square root 6 plus 6 would be my final answer. Okay, here I have binomials, meaning two terms, so that means that I need to FOIL. Okay, so negative 1 times the square root of 4 would be negative square root of 4. Negative 1 times 3 is negative 3. The square root of 7 times the square root of 4 is the square root of 28. And then the square root of 7 times 3 would be 3 square root 7. Okay? Right away here, the square root of 4, I know that is 2. So now this is negative 2 minus 3 plus the square root of 28 plus 3 square root 7, okay? I need to see if I can simplify these any further. So if I were to make a tree for 28, that would give me 7 times 4, and 4 is 2 times 2, so I do have a pair there. Alright, I'm going to go ahead and simplify this. Negative 2 minus 3 is negative 5, and now instead of the square root of 28, I have 2 square root 7 plus 3 square root 7, and now we've created some like terms. Okay, so 2 plus 3 is 5 square root 7. Okay, 2 plus the square root of 8 times 2 minus the square root of 8. You can go through the whole process and FOIL, or you could recognize that this is the conjugate. And anytime we have the conjugate, those middle terms are going to cancel each other out. So I can just do the first one times the first one, and the last one times the last one. So 2 times 2 would give me 4. And the square root of 8 times the negative square root of 8 would be the negative square root of 64. The square root of 64 is 8, and 4 minus 8 is negative 4. Alright, so now we're on to dividing. And to divide, I'm going to, since there's nothing that can be simplified here, I'm going to multiply. by the conjugate. So I'm going to multiply by the negative square root of 5 on the top and the bottom. So on the top, I would have negative 15 square root 5. And on the bottom, I have negative 5. All right, because remember, something times itself in a square root is just that number. 15 and 5 can be simplified. Negative 15 divided by negative 5 is positive 3 square root 5. Okay, same thing here. I need to multiply by negative square root of k on the top and the bottom. All right, so on the top now, I have negative 8 square root 3k, okay, because remember this is like a 1, so negative 8 times 1 is negative 8, and 3 times k is 3k. On the bottom, I have negative k. The only thing that I could do there is I have negative divided by a negative, so I could just simplify that into positives. So I have 8 square root 3k over k. No, you cannot simplify or cancel out these k's because one of them is inside a square root and this one is not. Okay, on 21, because we have both of them inside a square root, I would go ahead and simplify that first, meaning do the division first before we try and do any trees or anything like that. So 32 divided by 2 is 16. A to the 5th divided by a, remember the rule there is we're going to subtract the exponents. And b to the 3rd divided by b squared would be just b. And so now I have the square root of this whole thing. And now it actually simplifies really nicely because 16 is a perfect square. So the square root of 16 is 4. There in a to the 4th, there are 2 pairs of a's. And then that b is just going to stay inside because there's nothing I can simplify there. Okay, 22, again, we need to multiply by the conjugate because not everything is under the square root. So I'm going to multiply by 3 minus the square root of 5 on both the top and the bottom. All right, on the top, I am distributing. 2 times 3 is 6. 2 times negative square root of 5 is negative 2 square root 5. On the bottom, I could FOIL, but since it's the conjugate, I could just do first times first, which is 9, and last times last, which is negative 5. Okay, now simplify anything that I can. On the top, there's nothing I can do, so that's going to stay. And on the bottom, 9 minus 5 is 4. So now looking at everything outside of the radical, 6, 2, and 4, those are all divisible by 2. So I can simplify a little bit further. If you give me 3 minus the square root of 5 over 2. 23, same story. I need to multiply by the conjugate. So the square root of 5 minus the square root of 2 on both the top and the bottom. All right, on the top, I have to FOIL. 7, square root of 7 times square root of 5 is square root of 35. Square root of 7 times negative square root of 2 is negative square root of 14. Square root of 5 times square root of 5 is 5. And the square root of 5 times negative square root of 2 is negative square root of 10. Okay, that's on the top. And then on the bottom, again, because it's the conjugate, first times first, square root of 5 times square root of 5 is 5. And last, square root of 2 times negative square root of 2 is negative 2. Okay, then we would have to see if there's anything we could simplify on the top. So 35 is 7 times 5, and those numbers are prime, so I can't simplify that. 14 is 7 times 2, there's no pairs there, and 10 is 5 times 2, there's no pairs there. So everything on the top is going to stay exactly like it is. And then on the bottom, I'm just going to do 5 minus 2, which is 3. Okay. 24. Since you have both the top and the bottom, everything is under a root, we're going to do any division first. So 27 divided by, there's no coefficient here, so that's a 1. So it's going to stay 27. X divided by x, that's 0 or 1, so the x's are gone. And then y to the 7th divided by y is y to the 6th. So now I have the cube root of 27y to the 6th. 27 is a perfect cube. I don't need to make a tree. That's just 3. In y to the 6th, there are 2 groups of 3. And that's my final answer.